Welcome to QuantumX. In this episode, the construction team begins a unique project, building a two-story home from shipping containers. No longer an experiment, but a proven construction approach. From steel boxes designed to cross oceans, they're shaping a complete living space, defined structure, strong geometry, and a design mindset focused on long-term performance. This is not just about appearance, it's a technical challenge involving load paths, thermal insulation, vertical connections, and structural durability. By watching till the end, you'll understand how container housing can reduce build time, control costs, and fit perfectly into DIY, off-grid, and flexible living models. More importantly, you'll learn what works and what doesn't. Insights that only come from real-world construction experience. If you're interested in smart building and unconventional housing solutions, stay with us and watch this project through to the very end.
The concrete foundation's already been cast, level, precise, and dimensionally accurate. Above it sits a prefabricated H-section steel beam frame, prepared off-site to minimize tolerance errors and ensure load capacity for a two-story structure. At this stage, the team doesn't place the containers yet. Instead, they begin installing the timber wall framing. This is a deliberate decision. Timber framing reduces thermal bridging compared to steel and creates service cavities for insulation, wiring, and ventilation systems. The wooden studs are mechanically anchored to the steel beams, establishing a clear load transfer path from the container structure down to the foundation. Stud spacing is carefully calculated to match standard panel sizes and insulation modules, reducing on-site cutting and material waste. This approach reflects practical construction logic, separating the load-bearing structure from the enclosure system, resulting in better stability, improved thermal performance, and long-term build control.
Once the wall framing's fully stabilized, the team moves on to sheathing the entire surface with OSB panels. This layer is not merely for enclosure, it plays a critical role in the overall stiffness of the wall system. When properly fastened, OSB acts as a shear panel, allowing the timber frame to resist wind loads and torsional forces, especially important in long, narrow, container-based structures. Panel thickness is selected to balance structural performance with added weight. Joints are staggered, and all panel edges land directly on framing members to prevent sagging or cracking over time. Small expansion gaps are intentionally left to allow the material to respond safely to changes in temperature and humidity.
Once the wall systems gain sufficient rigidity, the crane enters the site. Two standard shipping containers are lifted one by one, with strict control over lifting points and balance throughout the operation. These containers are not placed on the timber walls. They're carefully lowered directly onto the pre-installed H-section steel frame. All second-floor loads are transferred straight to the steel beams and the concrete foundation, preventing deformation of the enclosure below. At this moment, the container reveals its true advantage: a ready-made structural steel box, repurposed as the second floor of the house. Before cutting into the container shells to form doors and windows, the team deliberately pauses interior work to address a critical structural step. The steel beam frame of the canopy is cleaned and coated with anti-corrosion paint at this stage. This is the ideal moment when the structure's fully exposed before walls, glass, or exterior finishes conceal the steel. The coating does more than prevent rust from moisture and rain. It protects load-bearing and vibration-prone elements, especially where the canopy is directly exposed to wind forces. With corrosion protection complete, The team begins cutting directly into the container shells. One large main door and a smaller secondary door are opened, both leading out onto the front canopy. Each cut is executed in sequence, panel by panel, to prevent sudden loss of geometric stability in the steel shell. On the side elevation, the original container cargo doors are fully opened. This opening will later become a full-height glass wall, introducing daylight and cross-ventilation across the entire second floor, a key advantage when container architecture is handled correctly. Immediately after cutting, reinforcing frames are welded in to restore structural continuity. Cutting into a shipping container is always the highest risk stage of the entire project. The steel shell is not just cladding, it actively contributes to load resistance and torsional stability. Before any cut is made, the load paths must be clearly identified: roof loads, live loads, and wind forces. A cut in the wrong location can lead to floor deflection, cracked welds, or irreversible deformation. When creating large openings, such as doors or glass walls, boxed or U-shaped steel reinforcement frames must be welded continuously around the cut edges. These frames replace the removed steel and restore stiffness to the container module. It's especially critical not to cut opposing faces at the same time. Each surface must be fully reinforced before moving on to the next. In container construction, speed is not the priority. Precision and deformation control determine the long-term performance of the building. Finally, the internal partition wall between the two containers is removed. What were once separate steel units are now merged into a single continuous second-floor space, larger and more open, while still relying on a carefully controlled structural framework.
A small window opened in the other corner of the container, overlooking the greenery, helps to create a harmonious space and avoid a cramped feeling.
Once all cutting and structural reinforcements are complete, the team applies a gray finish coat to the entire container exterior. Gray is not chosen for appearance alone. In container construction, this tone helps reduce heat absorption compared to darker colors, while also masking surface imperfections created during modification. The finish coat acts as a second protective barrier, working together with the anti-corrosion layer beneath. It significantly extends the service life of the container shell in harsh sun, rain, and humid conditions.
On the ground floor, before any glass installation begins, the steel reinforcement frames are fully welded in place. This step is essential when creating large openings in container-based construction. The steel frame acts as a load transfer structure, carrying all overhead loads so that no stress is imposed on the glass system. The ground floor glazing is designed with wide spans and increased height, enhancing visual openness and indoor-outdoor connection. To support this, the steel frame is typically built as a closed box section, tied directly into floor beams and steel columns, forming a continuous load-bearing loop. Only after alignment and weld quality are confirmed is the glass framing installed as a non-structural enclosure system. This approach allows the glazing to perform reliably, reduces the risk of cracking caused by settlement or movement, and ensures long-term safety at the most exposed level of the house.
At the canopy level, the team installs a glass balustrade system. This is a common choice in modern container homes, especially where elevated platforms and open views are involved. Glass railings preserve daylight and visual openness, avoiding the heavy appearance of solid metal barriers. In container architecture, where the structural language is already strong, glass helps visually lighten the overall form. Technically, a balustrade is not just a safety element. It must resist horizontal loads from occupants and wind. For this reason, the glass used must be laminated safety glass, often combined with tempering, ensuring that if breakage occurs, fragments remain bonded and non-hazardous. The fixing system is anchored directly into the steel beams of the canopy, never into finish layers alone. Connection points are designed to control vibration, while proper detailing ensures drainage and waterproofing at the base. A glass balustrade is only safe when correct materials and correct installation are both strictly followed.
On the second floor, after door openings and internal partitions have been cut, the team proceeds to weld additional steel reinforcement for the container walls and roof. Removing large sections of the steel shell significantly reduces the container's original stiffness. Without timely reinforcement, the roof can deflect and wall panels may twist under wind and live loads. Steel members are welded along the cut edges, tying directly into the corner posts and perimeter beams of the container. The goal is to restore a continuous load-resisting frame, allowing forces to be redistributed across the entire second floor. The roof area receives special attention. Container roofs are thin, and once lateral continuity is lost, they're highly susceptible to deformation from wind suction and thermal movement.
With the structural work complete, the team moves into the internal building systems phase. Electrical wiring is routed within the wall and roof framing, neatly organized and kept clear of direct contact with steel surfaces to reduce heat transfer and condensation risks. This is critical in container homes, where metal and electrical systems must be carefully managed. Next, thermal insulation baths are installed throughout the wall and roof cavities. These layers provide heat resistance, sound reduction, and help prevent internal condensation against the steel shell. A plastic vapor barrier is then applied across the entire surface. Its role is to block moisture from the living space entering the insulation layer, ensuring long-term performance of the wall system. Finally, gypsum boards are fixed to the framing. At this point, the industrial container shell begins to feel like a true living environment, ready for final finishes. Once the gypsum boards are in place, the team proceeds to seal all wall joints and gaps, creating a continuous surface. Even small openings can become air and moisture leakage paths. In container homes, a single unsealed joint can lead to condensation, mold, and significant heat loss. Once the wall system's fully sealed, the team moves on to installing electrical outlets and control switches. In container homes, this is more than a finishing step. It's a critical electrical safety checkpoint. All electrical boxes are isolated from the steel shell, reducing risks related to heat transfer and condensation-induced faults. Outlet and switch locations follow real-world usage logic, minimizing unnecessary cable runs and hidden junctions inside the walls. Each connection point is checked for grounding integrity and enclosure tightness. At this stage, the electrical system begins to function as part of a livable space. The site no longer feels like a construction zone, but a house approaching completion. In container construction, electricity must do more than work. It must remain safe and reliable throughout the building's lifespan. A large dining table sits at the center of the room. Its frame is fabricated from steel, fully welded, providing long-term rigidity without risk of deformation. The tabletop is cast in solid concrete, thick and stable. This material suits container architecture well: durable, moisture-resistant, impact-tolerant, and low maintenance. The combination of steel and concrete creates a material language that mirrors the building's structural logic. Here, the interior does not compete with the architecture. It continues the same construction philosophy from outside to inside. On the ground floor, every element prioritizes strength, practicality, and longevity, the core values of a functional living space.
On the ground floor, the finishing process follows the same sequence as the second floor. Electrical wiring is installed within the walls, followed by thermal insulation, vapor barrier installation, gypsum board cladding, and full sealing of all joints. This layered enclosure creates an airtight system, helping stabilize indoor temperatures and limit moisture transfer from the concrete slab below.
This shipping container house is organized with a clear vertical zoning strategy. The ground floor is dedicated to an open-plan kitchen and a large dining area, supporting daily living and social activities. This layout takes full advantage of the container's linear form, maintaining visual continuity, improving ventilation, and allowing flexible use of space. The centrally placed dining table acts as a natural gathering point, well supported by the high load capacity of the ground floor structure. Outside, the ground floor canopy area extends the living space, accommodating outdoor seating that faces the wide front yard. This transitional zone softens the boundary between interior and exterior, reduces direct heat gain, and expands usable space without increasing the building footprint. The second floor is reserved for private resting areas. A wide balcony paired with glass railings maximizes views in daylight while keeping the architectural mass visually light. Overall, the design reflects a practical, user-oriented approach, well-suited to outdoor living and aligned with the strengths of container-based architecture. The team proceeds to paint the entire interior of both the ground floor and the second floor. Wall surfaces are leveled one final time, ensuring the gypsum joints and sealed gaps are fully corrected. Only with a proper substrate can the paint perform as intended. The color palette follows a neutral tone strategy, improving light reflection within the typically narrow container space. It also allows exposed steel elements and raw materials to remain visually prominent by design. The final paint layer is more than an aesthetic choice. It serves as the last protective coating for the interior wall system, supporting durability and ease of maintenance over time. At this stage, the project transitions from a construction site to a fully usable living space. At the central area, beneath the staircase, electrical outlets and switches are completed, serving the main living zone and accommodating higher power equipment. The most notable feature here is the staircase connecting to the second floor. Its structure is fabricated from wide, solid steel plates, welded and bent into shape. There are no hollow frames or lightweight components. This staircase functions as a single, rigid steel mass, transferring loads directly to the floor structure. It is a solution focused on long-term stability, fully aligned with the core principles of container-based construction: strength, clarity, and safety.
On the second floor, once the sleeping areas are defined, the team begins by installing an insulating foam layer over the floor. This layer separates the finished floor from the container's steel structure, reducing heat transfer and limiting impact noise to the level below. In container homes, this step is essential for achieving real living comfort. Above the insulation, wood-look flooring panels are laid. The material is lightweight and dimensionally stable, adding minimal load to the second floor structure, while providing warmth and comfort in resting areas. This flooring system balances technical performance with daily usability, making it well suited for upper levels in steel container construction.
The steel staircase is coated in black, creating a strong visual contrast. This contrast is not purely aesthetic. The black finish preserves the staircase's structural identity, clearly expressing it as a load-bearing steel element, rather than blending into surrounding surfaces.
Once the interior finishes have fully stabilized, the kitchen cabinetry and countertop system is installed. Cabinet frames are anchored directly to reinforced wall structures, ensuring they can support countertop loads and long-term appliance use. In container homes, all wall-mounted elements must account for potential vibration and thermal movement from the steel structure behind. The kitchen island and counters are arranged in an open layout, directly connected to the large dining area, maintaining short, efficient circulation paths within the main living space. Next, kitchen appliances are positioned: the cooktop, sink, oven, and ventilation system. Each unit is leveled and connected to dedicated electrical and plumbing lines, making future maintenance straightforward. At this stage, the ground floor is no longer just finished, it is fully functional, ready for everyday use as the operational heart of the house.
From raw shipping containers, this project has been completed into a two-story home with clear spatial organization, controlled structure, and real-world usability. Each stage reflects intentional construction thinking, separating load-bearing systems, cutting containers in the correct sequence, managing insulation, moisture control, and electrical safety. The factors that ultimately define long-term performance in container housing. This is not a project built to showcase form alone. It is a practical, durable, and replicable solution for those interested in DIY builds, off-grid living, or flexible housing. If you found value in this project, like the video, share your thoughts in the comments, and subscribe to QuantumX for more in-depth construction projects like this one. There's much more to come. Thank you for watching.